All right, this talk's called The Black Art of Binary Hijacking. Just tried to come up with a clever title. It's not really a black art. It's fairly straightforward, but something that hasn't been particularly automated in the past, and that's what I'm trying to accomplish here. So first off, I'm going to talk about a little bit the overview of persistence techniques, how malware stays persistent, or how a pen tester would essentially get something to be persistent on a network if that's what he's trying to do. I'll talk about the binject tool, which is basically my approach to automating persistence through binary hijacking specifically. And I'll go through some of the major techniques it supports. That actually supports quite a few other things that I'm not going to talk about, but you can download it and run the tool with the -H option and see some of the other things it supports. It supports a few different process injection style parasites. I'll talk about those. And since I'm on the topic of process injection parasites, I'll talk about a new method for process injection that will be implemented soon in the tool. There's already space for it in the command line options, but it's not quite ready for prime time yet. All right, so persistence mechanisms on a Windows system. The most easy is the startup folders. Of course, all you have to do is copy a file over there. Very easy to detect. Same with the registry run keys. As you move on down this list, you can see kind of the level of difficulty required to install something is pretty much matches how difficult it is to detect. The very last one on the list is what I call DLL search order hijacking. It's still very easy to install, very, very, very difficult to detect. This is not what this talk is about. We have a blog post about that I wrote week and a half, 2 weeks ago or so. I recommend you going out to the Mandiant blog if you haven't read that blog post. But anyway, the next lowest one down on this list here is binary hijacking. Still pretty difficult to detect from a forensic perspective. This basically involves, just taking a binary that does something already that is loaded when the system boots and just adding functionality to it. All right. So what binject is, it's a pretty simple command line interface tool. You just run it. It only has a few command line options. Really hard to mess up. But it does a lot of functionality. And really the tools and the impetus for me writing this tool is that I've been writing these techniques in individual little one-off programs for the last, 4 years or so. And I finally just decided to consolidate them all and make one kind of all you need to infect binaries kind of tool. And this isn't necessarily just malicious, like I said. I'll talk about some legitimate uses of some of this stuff in a minute. But anyway, one of the things you can do is the most basic thing is just add new sections to a binary. Nothing particularly groundbreaking about that. It does have a very good algorithm for adding sections. And if we have time at the very end, and I can pull up PEView and show you some examples. I can show you where my tool succeeds and other tools fail. But if you just wanted to add data inside a binary, to, very crude steg or something like that, the tool supports it. Basic entry point redirection. So if you add on a new piece of data, you can specify the permissions of that section. So you can say you want it to be an executable section. And we can very easily just redirect the entry point of the binary to that section. So now when this binary starts up, it's going to start executing your code instead of the real code. That's just what I call entry point redirection. It also supports entry point hooking, which would be something like this. This is an entry point hook stub for a DLL. So when you have a DLL, the problem with a DLL is it's going to be loaded anywhere in memory. You don't have any really way to guarantee where that DLL is going to be loaded. And with a hook, an entry point hook, we want our code to run first and then at some point jump back to the original code so that the DLL works as intended. So I just prepend this little sequence of instructions here. What I basically do is I take the delta, which is the difference between the memory address right after the call instruction and where the original entry point is, and using this sequence, I'm actually able to build up a real pointer in memory and push it on the top of the stack to your shell code. So all you have to do is make sure your shell code will take basically a parameter, and you can use that. You can jump back to it at the end, or you just do the return instruction, and the return will actually jump back by default to whatever's on the top of the stack. So pretty simple system here for doing entry point redirection. That's a very basic feature. Here's the feature we use more often in our line of work, entry point table poisoning. So I have the ability to modify the import table to add on imports. This technology's been around for a while, particularly with the Microsoft Detours library. However, the Detour library will add it, I think, by default to the very end. I'm not sure if there's a way to modify that behavior. So when a binary loads, it basically walks through the import list of all the DLLs loaded, and it loads them in that order. So that the trick of mine is that whenever you say you want a specific DLL to be loaded, it will actually load first and not last. We use this system for kind of an internal project where we want to do some behavioral analysis on malware. So we want some of our code to execute inside the process first before the malware executes. So all we do is we packaged our code inside of a DLL, and we use the entry point or the import table poisoning to force the binary, no matter how it's launched, it can be launched as a service or whatever, no matter how it's launched, it's going to execute our DLL before it does anything else in the process. Even the entry point, DLLs get loaded and executed before the entry point. So, another thing we got happening here is the automated installation of TLS callbacks. Some of you might be familiar with this. It's kind of one of those somewhat malicious techniques used out there. Not all that common, though. This is initially a thread, part of the whole thread system. You can have threads that have their own unique pieces of memory, and you can have callback functions that can initialize them. But basically, why this is useful from an attacker perspective is TLS callbacks execute before the entry point of a binary. So if you attach a little piece of malicious code to a TLS callback in a binary, you have full access to do anything to that process before anything in the binary runs. So if you wanted to have some anti-VMware or anti-debugger detection, TLS callbacks are a pretty novel place to put that data, because when you open it up in Ollie debug with default settings, the TLS callback is already executed. You don't, it's not automatically going to pause at that location. You can configure it to pause, but it's not the default behavior. And this is, of course, if user32.dll is loaded. Something in the user32.dll call chain actually forces these things to be loaded. Oops. And as I was saying, this is a fairly easy to use program. So all you have to do to force a TLS callback to be created with your code, your shell code that you could have generated with Metasploit, is this simple little command line down here at the bottom. binject-i, you give it a clean executable, -o, you give it an output executable, -d, you specify your data, which in this case would be shell code, and you just say -t or -tls, and it's going to install that block of data as a TLS callback. There's some other utility wrapping functionality. Right now I have the basic command line wrapping. So this tool, the whole idea of this tool is we want to add functionality to an existing binary, a compiled binary. There's lots of, somewhat malicious or behavioral analysis type uses for that, but I also have some basic command line uses for that. One of them being, I have a binary and I just want it to have a fixed command line, so I can just double click it and it's always going to run with this specific set of arguments. So here's an example of wrapping netcat.exe to make it a persistent, a backdoor that all you have to do is make sure netcat gets launched, and it's always going to get launched to create a reverse shell. This reverse shell will connect out to fake.com on a certain port and launch command shell connected to it. Eventually, I'd also like to get a function put in here to attach, a fixed set of standard input to a binary, that sort of thing. And the whole thing works via entry point redirection. So I redirect the entry point before the process starts. I get all this stuff set up. I change around the command line arguments and all that stuff in memory. It works pretty well. So that's the basic functionality. Just you have a piece of shell code or something like that that you wrote completely from scratch. It does everything you want it to do. So any more advanced functionality you would have to write on your own with those features. I do have the ability to add in some pre-made parasites. So for example, we had some shell code or something that we wanted to actually not just run before the binary, but we wanted to actually be process injected into something else. So if I have a piece of shell code I wanted to be process injected into services.exe, I can use there's a couple different methods for that. Well, the first thing you have to do when you're process injecting is, you have to allocate memory in the process, then you have to write your data over there with these two function calls normally. Getting the code to execute, there's a couple different methods for it. The first most common one is create remote thread. This will basically force another process to start executing at a location of your choosing. Once you've allocated memory there and you've written your code there, it doesn't take a rocket scientist to figure out that this could be potentially malicious as well. This pretty much always works. Create remote thread. There's some cases now with Windows 7 and above where they're starting to restrict the usefulness of this, but for the most time, it always works. Other techniques like QUser APC, there's not much documentation out there on them. They're not very popular techniques. QUser APC will force a process that supports APC, which is asynchronous procedure calls. It will which is basically a queue of functions that process is going to execute whenever it works on this APC mechanism. Not all processes do. There's some key processes that do use APC. For example, services.exe uses asynchronous procedure calls. So you can use QUser APC to force services.exe to execute something of your choosing. So it's pretty effective in that case. It wouldn't be effective against, say, like, you couldn't QUser APC against netcat. It doesn't use APC. It doesn't make those function calls, so it's never going to process an APC function that's added to its queue. Another technique, it's not fully implemented in my tool yet, so I went ahead and posted the proof of concept code on my website along with the tool. So you can at least see how I'm doing this technique, and it'll eventually make its way into binject as well. So here's another technique. Instead of create remote thread and QUser APC, in order to get code to execute in that process at our specific location, this basically technique called thread hijacking. What I do is I find a thread that I want to hijack, which would typically be like the main thread of a process. So if I find services.exe, oh, that one's going to be kind of dangerous, but I would find maybe explorer.exe. We suspend the main thread. I do a get thread context to save off all the register context. Then I allocate space for my new code. And the key difference here is I also allocate a new stack. So I'm going to make a completely new stack, completely new area for my code. What's not in the slides here is that I actually do kind of a loop with the get thread context. I'm basically checking to see if I'm executing inside of ntdll. If I'm executing inside of ntdll, chances are I could be waiting for an operating system function to return. It gets problematic when you try to resume after you've cleared out your malicious code. If you're waiting for that to resume, you can get a lot of crashes that way. So I actually execute in a loop with get thread context, waiting for EIP to be outside of ntdll. That's a side note, though. So all you want to do is save off that thread context, allocate your new code, your new stack, set thread context to set EIP to the new code, and set the stack pointer to the new stack. Then you can just resume the thread, and that the new code that you allocated in that process is going to start executing, which is pretty neat. That in and of itself is somewhat useful, but then you've just broken the entire original process. That's not cool, especially if it's explorer.exe. They're going to kill the process pretty quickly. So the difference here is now we're going to actually, whatever shellcode you injected over there, it has to basically suspend itself when it's done. Just call suspend thread and call it a day. Once you've suspended yourself, the actual whatever process is doing the hijacking can then set thread context back to the original context and then call resume thread. So what we've done is we've taken a thread, which is normally would just keep executing whatever it wants. We've stopped it, we've hijacked it for a period of time, and then set it back to the original. So in that period of time, it actually continues going as if nothing ever happened. It has no knowledge that it was ever taken over and hijacked for any length of time at all. Some notes on that. Why in the heck would anybody ever do that? A little bit of less of a memory forensic residue. There are some traces that threads might have been launched via create remote thread, and certainly APC function calls would have their residue as well. If we hijacked the main thread and launched launched a new thread from there, the thread start address would be originating from someplace that it would be originating from within that process as opposed to being obviously a remote thread start. And my website where you can get this stuff is my rnicrosoft.net. It's not Microsoft, it's me. Let's take a quick peek at the binary. So I'm just going to run binject here with a -h. Actually, let me make this a little bit bigger. I forgot. Properties. Font. 20. Okay. All right, so when it ran it with the -h option, you can see all the different command line parameters it takes. I didn't talk about every single one of these, but you get the idea. What I have in this directory is a little block of shellcode, which is just going to pop up a message box, and I have notepad.exe here. When I run this notepad.exe, it just runs. It does its normal notepad stuff. That's kind of cool. I can use binject. I can say -i notepad.exe -o hacked notepad.exe. I'm going to say -d and give it my message box shellcode. What I'm going to do now is give it that -t switch. This is going to force the message box shellcode to be a TLS callback. And it just runs. It doesn't spit out anything. Like I said, very simple, easy to use tool. Now when I run hacked notepad, first thing that pops up is this, lol Blackhat, I'm in your process, and then notepad runs. That's pretty cool, but you could have achieved the same functionality there with an entry point redirect. Let's actually take a look at the binary. I'm going to pull it up real quickly in PE view. You see what it did was add a section called .nic down here at the bottom, and inside of that is our TLS directory, and we have a TLS callback pointer sitting right here. So it's done all this stuff. It's made the section. It's set up the callbacks and every piece of data in here that will actually make this thing work. And inside of that callback is, of course, our malicious code. And when you pull this up in IDA, the first thing you're looking at, the entry point itself is completely unchanged. This is the normal entry point of notepad.exe. So it's a little bit stealthier than an entry point redirection right there. So another kind of advantage of binject, and I think I mentioned something about it earlier about being, it has a pretty good algorithm for actually adding sections to a binary. What a lot of people do when they try to add sections to a binary is just they see, okay, my section headers are here, it's an array. I'm just going to go to the next offset and add another section header, and everything will be magic, because it's always going to be nulls there. There's always going to be plenty of padding. There's no problem. Problem is, you're not always going to have plenty of padding, and notepad.exe is one of those specific examples where you do not have enough padding. I have enough padding for one section maybe, but I think in this particular example, if I add two sections, I'm actually going to be overwriting part of my import table. That's going to be bad news. So inject -i -o. So here I just ran binject to create another new notepad.exe. I'm just going to rerun this command again with the input being itself. And I'm going to just keep doing this over and over and over. I'm going to make a bunch of sections. Now I'm going to PE view that. And you can see, of course, it made a whole bunch of sections here. So clearly I've exhausted what I could have achieved using the slack space in the header section of this PE binary. So what it's actually done, if I notice the first section of this binary actually begins at the offset 600 instead of the original 400. So what binject does is actually completely restructures the binary if it needs to. If it is able to detect that it doesn't have enough slack space left in the end of that headers, it detects that there's something there, like the import table, it's actually going to restructure the binary such that it can actually make space if it needs to. So it's pretty well done in that perspective. And a lot of these basic features, like adding the import DLLs and stuff like that, are pretty hardened because we're using them. Been using them for a while on internal projects, so that they work very well. Anything that's edgy might not be as flushed out, and you might get bugs and crashes. But some of this stuff is pretty good. So, any questions? Just deer in a headlight. Okay. All right. Well, thanks. Once again, here's my information. Nick Harbour. And the tool, the binject, and the proof of concept for the new process injection technique is on my website. You can download it, whatever. Give me your thoughts. And thank you.